A very warm greetings to everyone. So this is a video demonstration in continuation with the previous one where I was talking about the hierarchical clustering analysis using the employee absenteeism data. So as you can see on the screen, I have already performed the execution part and I'm here to talk about the discussion and the strategic implications. So first let's take the hierarchical clustering view. So if you look into this particular view, the clustering results bring to light meaningful behavioral patterns among employees that can help the HR team in the decision-making process. Let me give you an example. Say for example, the first clustering. Employees can be considered baseline performance with minimal management intervention needed. So they can also serve as a very peer role models in engagement programs. So that can be one of the decisions. Second cluster, employees might benefit from behavioral monitoring, mentorship, or performance discussions to prevent progression to more problematic attendance patterns. That also can be one. If you take the third clustering, then represents a critical group. The HR should explore if external factors like transportation related fatigue or age related stress or behavioral dissatisfaction are influencing their behavior. Let us look little deep into this particular diagrammatic representation. So this is a classic dendrogram, which looks like a tree diagram that visually represents the hierarchical clustering structures, which is derived from previously calculated distance matrix. So we use the Elucidine approach. So what about the description of this visual? The x-axis, it represents the employee records, that is a row, one, say for example 130, 116, likewise it goes. The y-axis shows the distance or dissimilarity between the data points as they are merged into multiple clusters. So each merge points, that is a node, shows what distance two elements or two clusters were joined. The higher the branch, the greater is the difference between the clusters before merging, right? The higher the branch, the higher is the difference between the clusters before merging. So what is the key observations? Some records, say for example row 564 or 568, are merged at a very low distance, suggesting that there's a very high similarity between those employees either based on the age or transportation expenses. In contrast, records such as row 130 or row 503 are merged only at a very higher vertical distance, which means there is a greater dissimilarity. The tree forms 3 to 4 major branches, which is suggesting a natural cluster cut at that point. So what is the inference what we write here? The dendrogram confirms that the employee dataset contains a distinct behavioral or a demographic cluster. The vertical distances between the merges help identify optimal clustering threshold. So based on the visual inspection, 3 or 4 clusters seem very meaningful along with a typical HR segmentation, which can be segmented into low risk, moderate risk, or high risk absenteeism groups. So this is how this particular dendrogram diagram has to be really looked into. And you can also look into the distance. The second, we also have a heat map here. This colored code matrix represents the normalized values of two selected variables, that is age and transport expense. So one is age, the other one is the transport expense across multiple employee rows, that is across multiple employee rows here, right? You can see it goes. So the data has been arranged like this. So what is the description of this visual? Each row in the matrix represents an individual employee, that is each row. Say for example, row 8, row 18, etc. Each column represents a variable, that is age or the transportation expenses. The color scale ranges between dark purple, that is the value near to 0, or to orange where the value is near to 1, as indicated by the legend. Let's talk about the shades here. The darker shades indicate lower values, that is younger employees or lower transportation expenses. The brighter orange shades are indicating higher values, that is the older employees or the higher transportation cost. So what is the key observations here? What are the key observations here? Some employee, say for example, let's take row 8 or row 81. Row 8 or row 81 here. Or row 85. It shows a high normalized value, that is bright orange for age, but low values, that is purple for transportation expenses, or vice versa. So several rows shows consistently high values for both variables, likely representing a segment of senior employees with higher transportation cost, whereas others shows low values for both, that is possibly indicating younger employees with minimal transportation expenses. So how do we write the inference for this? This heat map helps us to visualize variations and patterns in key absenteeism related dimensions across the workforce. It indicates that diversity is existing in employee profiles and supports the decision to use a hierarchical clustering for segmenting these behaviors. It also validates the pre-processing step of normalization, as we can now fairly compare variables with different original scales. So I hope you understood the inference and the meaning for both, that is the dendrogram diagram and also for this heat map. So how do we do a cross interpretation, that is from visualization to an actionable segment? So when this heat map and dendrograms are interpreted together, the heat map gives a fine grained view of how employees behave across a selected variable. But however, if we look into the dendrogram, it offers a structural view of how similar or different are the behavior of employees, right? So how do we look into it? You can put the data into three different clusters. Cluster A, employees with low age and transport expenses, possibly entry level or early career individuals. Cluster B, employees with high transport cost but moderate age who may face transportation fatigue. Cluster 3, employees with both high age and high transport cost, potentially indicating a retention risk group because of high absenteeism likelihood. If you can do better analysis, you can also take into consideration the BMI, that is a body mass index, of those senior citizens and do a predictive analysis whether they might face any medical health in the nearby future. Let me also showcase to you one of the most other important analysis, that is the bar chart. The bar chart here illustrates the average values of age, which is in blue, and the transportation expense, which is in orange, for each of the three clusters, that is cluster 1, cluster 2 and cluster 3. For representation, it has been mentioned as cluster 0, 1 and 2, derived from the hierarchical clustering process. So how do we look into this particular chart summary? X-axis talks about the cluster labels which has been assigned, that is 0, 1 and 2. Y-axis talks about the average value of the variables, that is age and transportation expenses. And the legend, blue bars is equal to age and orange bars is equal to transportation expenses. What about the observation and cluster-wise inferences here? Cluster 0 here, right? Age, which is 29, which is very much moderate. Transportation expense 0 is negligible. How do we look into the interpretation for this? This group likely represents younger employees who live close to the workforce or possibly benefit from company-sponsored transport. They may represent a low-risk segment in terms of absenteeism related or to the commuting stress. Let's look into cluster 1. Age 22, lowest among all the clusters. Transportation expense probably around 83, highest across all clusters. So this cluster includes young employees incurring a higher transport expense. This pattern may indicate employees who travel from a very faraway location, perhaps due to affordability or housing or lack of nearby accommodation. Despite their age, they might face a transport related fatigue. This increases the likelihood of occasional absenteeism. This cluster may benefit from travel allowances or shuttle support. So can the organization take into consideration by providing accommodation facilities within the premise? Let's look into the final cluster. Age 30, and probably if you look into the transport expense, it is around 20. And how do we look into this particular interpretation? This group is composed of older employees with moderate transport expenses. They may have moderate, stable routines or seniority based roles and possibly access more optimized transport options. While they may not show absenteeism from commuting stress, it might be related to age related health or family responsibilities. Could influence their attendance, it might or might not, but maybe when we link further data that can be found. So what are the strategic insights from the cluster bar chart? Age and transport expenses are not linearly correlated. So the grouped bar chart provides a very quantitative overview on how employee clusters differ in terms of age and transportation expense. These differences reflect deeper structural and behavioral patterns within the workforce. Cluster 1, despite being the youngest group, emerges a potential absenteeism risk due to high commuting cost. In contrast, cluster 2, with the highest average age, might face a different set of challenges tied to age-related attendance behavior. And cluster 0, having balanced value, appears most or more resilient. These visuals inference validate the utility of hierarchical clustering in revealing actionable HR insights and guiding policy interventions, which can be tailored for supporting the employees and other subgroups. So I hope the entire clustering analysis using The hierarchical clustering approach was very useful. Let me meet you with another video explanation with another clustering model.